Hi guys, here we have some examples of using the sine and cosine rules, in particular with the ambiguous case, which applies to the sine rule. The ambiguous case can occur only with the sine rule. So first of all, when do you choose what? Well, you need to use the cosine rule when in your triangle you are given 3 sides or 2 sides and the included angle. And that's important, it's the included angle. If you don't have that, but you have just 1 side and 2 angles, or maybe 2 sides and a non-included angle, then you use the sine rule. But as said, then beware of an ambiguous case, which can occur when the smaller of the 2 given sides is opposite the given angle. Okay, so let's have a look. Here we have a little problem. There's no triangle yet, but there's going to be a triangle A, B, and C. C is somewhere on this line, such that BC is 6. And what I want to find out is the angle at C. That's the objective, find the angle at C. So what you could do is just take a segment of length 6 and draw it in. So there you go. Yeah. C, BC is right there. So here's going to be point C, and BC is 6. All done. And how do we find this angle here at C, theta? Well, you use the sine rule. So theta, the sine of theta over 10, that's what the sine rule says. The sine of theta over 10 is the same as the sine of 30 over 6. We work that further out. Work it out further, I should say. You get the sine of theta is 10 times the sine of 30 over 6. Now the sine of 30 is 1/2. I know that because I'm a maths teacher. And 1/2 times 10 is 5. So from this it follows that the sine of theta is 5 on 6. All good. So theta is going to be the arcsine of 5 on 6. Which is, if I get it right, 56.4 degrees. So this angle is 56.4 degrees. But there is an ambiguous case, because I haven't done it quite correctly. I've just assumed that this segment BC is like this. But the same segment with the very same length. Now I could copy that segment there and I could put it here with the same length, 6 again. So hey, wait a minute, C might be not here, C might be here. Let's call it C with an accent. Now that's the ambiguous case, because if C turns out to be here, then my angle theta here, not theta 1 but theta 2, is quite a lot bigger than theta 1. But still the whole calculation is the same. The sine of theta over 10 is the sine of 30 over 6, blah 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 blah. So theta is the arcsine of 5 over 6. And your calculator will only give you this answer here. But this answer is the answer for theta 1. So what is the answer for theta 2? Well, the ambiguous case says if your first answer is theta 1, then your second answer, and it always works like that, theta can be pi take away your first answer. Well, pi is in radians. Here we work in degrees. So really, I should have said 180. So let me fix that for you. (180) take away 56.4. So that's 123.6. So that's theta 2. This is theta 1. So always, when you solve the angle of a sine function, so you use the arc sine or the sine -1, the answer that your calculator will give you will be the smallest possible answer. But there is also a bigger answer, which you can get by doing 180, take your first answer. So there's the ambiguous case. Important. Now, similar problem. Sorry. Suppose in this problem here, BC is 5. Not 6, but 5. Again, now that we're not a fool, you know, we know about the ambiguous case, so we know that there might be two answers. We know that this could be an answer, and we know that there could be another answer there, which is quite the same. I'll put it there. So this length is 5. This is also 5. So C could be here, C1, or C could be there, C2. Yeah. Okay. So we didn't fall for it. We're taking into account the ambiguous case. Let's see what happens. And we're looking for the angle theta, theta 1 and theta 2. So 5, or that 5 doesn't matter, 5 over the sine of 30. I'm going to toss it around. Sine 30 over 5 is the sine of theta 1 or 2 over 10. That's what the sine rule says. So again, sine theta is 10 sine 30 over 5 this time. Hey, wait a minute, sine 30 is 1/2. 1/2 times 10 is 5. 5 over 5 is exactly 1. So sine theta equals 1. So theta is the arcsine of 1. Now you don't need a calculator for that. When is the sine 1? Only when you have a 90-degree angle. So the angle at theta, theta 1, is 90 degrees. According to the ambiguous case, therefore, theta 2 is 180 take 90. Hey, wait a minute, that's also 90 degrees. So theta 1 and theta 2 are the same angle. So my sketch here is just a bit off. There is no C1 and C2. The angle theta 1 is the same as the angle theta 2, which can only happen when they are the same. And the angle is 90 degrees. So this is a right angle triangle. And there's only one C. So it turned out there was no ambiguous case after all. Only one C is possible. And it's a right angle triangle. In the third example, we will say BC is 3. And again, we're still after angle C, right? the angle at C. Now if BC is 3, then you could draw it in, you know, again, there's ambiguous case there, la la. So they're both 3. C1 is here, C2 is there. No. You do the maths, so there we go again. Sine 30 over 5 equals the sine of theta, so there's theta again, there's another theta, over 10. Rearrange it and say sine theta is 10 sine 30 over 5. Sorry, I'm messing it up now, big time. We're no longer working with 5, we said 3, sorry about that. BC equals 3, so sine 30 over 3, and here over 3. Sine 30 is 1/2, 1/2 times 10 is 5, 5 over 3. So the sine of theta is 5 over 3, which is a fraction bigger than 1. So theta is the arc sin of 5 over 3, a fraction bigger than 1. Now you can key in anything you like on your calculator, but you're not going to get an answer, because the sine of an angle can as a maximum only be 1. Right? Unit circle, the sine is 1 when it's here, 90 degrees, or -1 when it's there. It can't be bigger, it can't be smaller in the unit circle. So 5 over 3 is not possible. Not possible. Not possibly. See? Therefore, there is no answer. Okay, but if there is no answer, how come I could draw a triangle here? Well, it turns out that I really can't. I cannot draw a triangle there, because 3 centimeters or 3 units just doesn't make it to the other side, no matter how I try. They're too short to reach that line anywhere, which we sort of knew from the previous example, because, you know, it took 5 to get exactly to the line, shortest path. So 3 just doesn't cut it. No answer, no triangle. And we use the sine rule in all the 3 cases to establish this. Now, final example is for the cosine rule. The cosine rule you can use when you've got 3 sides given, or maybe 2 sides and an included angle. Here we've got 3 sides given. And let's find out again what the angle at C is, theta. Well, you plug it into the cosine rule. You just say c squared equals a squared plus b squared, take 2ab cosine c. Well, that's convenient because I'm after that c there. That c is my theta, right? The angle at C. Convention says that if this is C, this side is little c. If that's B, this side is little b. If that's A, this side is little a. So there we have my A, B's and C's. So let's fill it out. So c squared, that's 7 squared, equals 5 squared plus 8 squared, take 2 times 5 times 8 cosine theta. Okay. 49 is 25 plus 64, take 80 cosine theta. I'm going here now. 25 and 64 is 89. I'm going to take small steps. 49 is 89, take 80 cosine theta. I'm going to move the 89 to the other side. 49, take 89. That's negative 40. Negative 40 is negative 80 cosine theta. I'm going to divide both sides by negative 80. Yeah. And I'm going to flip it around as well. So cosine theta is negative 40 divided by negative 80, which is 1/2. So theta is the arc cosine of 1/2. There's no ambiguous case with the cosine. The arc cosine of 1/2 is 60 degrees, or in radians, pi on 3. And there's your answer using the cosine rule.